Hi, I'm John O'Hanion from Luna Innovations, and I'm excited to share with you our new fiber optic pressure sensors we are developing for military aircraft applications. Luna is a leader in fiber optic sensing and telecommunications test and measurement equipment. Our mission is to enhance the safety, security, and connectivity of people by leveraging our expertise in fiber optic-based technology and the information it provides. We were founded over 30 years ago with SBIR funding and have grown our business to the extent that our commercial product sales heavily outweigh our SBIR research funding. Luna stock is traded publicly on the NASDAQ Stock Exchange, and our 2021 revenue was $87 million. Our contract research allows us to develop new technologies and apply our existing products in innovative ways that develop new markets. In this Phase 2 Navy SBIR, Luna is addressing the critical need in the military aircraft community for reliable pressure sensors. In particular, this project is focusing on pressure sensors integrated in the electro-hydrostatic actuators, or EHAs, that position the flight control surfaces of the F-35. The existing pressure transducers for hydraulic actuators are complex, expensive, and are prone to reliability issues. There is a need for pressure sensors that are robust to pressure spikes up to 6,000 psi, low size, weight, and power, that are low cost, reliable, and immune to electromagnetic interference, or EMI. Luna has set out to solve this problem with our innovative fiber optic sensing technology. Pressure sensors in EHAs provide valuable feedback data for controlling the actuators, as well as detecting anomalies and failures prior to launch and during flight. Increasing the reliability of pressure sensors for EHAs will benefit the Navy and original equipment manufacturers, or OEMs. Fiber optic sensors will be lighter, reduce copper wire weight, and are less prone to breakage. This will result in higher uptime for the fleet. The versatile fiber optic sensing system can multiplex hundreds of sensors to replace legacy sensors throughout the aircraft that measure temperature, strain, pressure, vibration, or acoustics. In the end, Lusa's sensing technology will enable safer and more cost-effective operation of the F-35 Lightning II fleet. Luna's solution is to combine two fiber optic sensing approaches to achieve robust and temperature-compensated pressure measurements. Fabry-Perot interferometers are extremely sensitive and are well suited to measuring pressure in extreme environments. However, they are typically also sensitive to temperature. Adding a fiber Bragg grating, or FBG, to the same sensing assembly allows for an independent measure of temperature and the ability to compensate the pressure sensor calibration for temperature effects. Sensors can be daisy-chained together using wavelength division multiplexing, or WDM, which means each sensor uses only a portion of the wavelength spectrum. Through this approach, a single fiber optic interrogator could measure the pressure in every actuator throughout the aircraft. For this project, we are adapting our commercial Hyperion interrogator for military flight applications. The fiber optic pressure sensors are robust to pressure spikes and EMI, which will improve the reliability of EHA systems. The current status of the technology development is based on the achievements in Phase 1 and the ongoing effort in Phase 2. The Phase 1 base and option proved the feasibility of the approach and achieved TRL-4. We combined extrinsic Fabry-Perot interferometers, or EFPIs, with FBGs in one assembly, as seen in the photograph. The sensors were packaged in rugged stainless steel housings and were proof tested up to 9,000 psi. The sensors demonstrated accurate pressure measurements during temperature disturbances. During Phase 2, we are optimizing the performance of the sensor and maturing the manufacturing methodology. Environmental testing using mil-spec 810G will be performed. The project will culminate with an on-site demonstration at a military aircraft manufacturer. Phase 2 has already achieved TRL-5 and is aiming to reach TRL-6 during 2023. This chart enumerates the many advantages and benefits the new fiber optic pressure sensors provide. Optical fiber can operate in very high temperatures and is inherently immune to EMI. By combining pressure and temperature measurement into a single sensor, it enables built-in temperature compensation and provides an in-situ temperature reading in the hydraulic fluid. This will allow for reliable pressure readings under all conditions. The pressure sensors being proof tested to 9,000 psi exceeds the current requirement of 6,000 psi and bodes well for surviving pressure spikes that damage legacy pressure transducers. This robustness will increase the life of the sensor and reduce fleet downtime. The ability to multiplex sensors reduces wire weight and provides versatility for the future. Basing the flight system on the Hyperion Interrogator provides a strong starting point with a proven track record of performance. We are designing the new pressure sensor to be a drop-in replacement for the existing EHA pressure transducer with the exact same form, fit, and function. This allows for gains in reliability with minimal impact to the aircraft design and certification. With the success of Phase 2, the pressure sensors will be well positioned for transition to the F-35 fleet or other future aircraft. Luna is working closely with the Navy and OEMs to understand the concept of operations and ensure we are working towards meeting every requirement. Follow-on tasks to Phase 2 will include flight qualification and flight testing, culminating with acceptance testing by the Navy. Deployment to the F-35 fleet would be accomplished by PEO JSF. However, there are many aircraft platforms that stand to benefit from this new technology, such as the F-18, F-22, V-22, and commercial aircraft. Luna and its team of partners will bring the new fiber optic sensors for aircraft hydraulics to market. The first transition target is integration in the F-35. Luna will work closely with Lockheed Martin to accomplish this goal. Luna recently developed a rugged handheld interrogator in collaboration with Lockheed Martin for the F-35 fiber optic avionics network, as seen in the photo. Luna is interested in meeting with PEO JSF personnel to discuss transition and testing opportunities. Thank you for listening to this briefing, and I hope you can see the value in this new technology and what it can do for the U.S. military aircraft fleet. Higher reliability means less downtime and lower operational costs. Please reach out to me if you are interested in learning how this sensing technology can help solve your problem. At Luna, we are enabling the future with fiber. Thank you.